Okay, we're going to start with Unit 2, Lesson 1. And Unit 2 is going to be on complex numbers. So we've gone through what whole numbers are, integers are, rational numbers, and irrational numbers. And the last that we're going to talk about is imaginary numbers. Now, imaginary numbers are the square root of a negative number. For instance, if you have I is the square root of a negative 1, and I squared is the square root of negative 1 squared. And the square root of a negative 1 times the square root of a negative 1 is negative 1. So let's go down here. It says imaginary numbers. Now it says rewrite using I. So the square root of a negative 5, so let's write this down. The square root of a negative 5 is simply going to be 5i. And the reason why you have to have this I here is because you can never have a negative under a square root. And if you have a negative under a square root, then that number simply becomes an I. So the square root of a negative 5 is 5i. Let's look at the second example. It says 3 square root of a negative 4. So 3 square root of a negative 4. Now, the square root of a negative 4 becomes 2i, because the square root of 4 is 2, and then it's a negative, so it becomes I. So it becomes 3 times 2i, which is just 6i. Okay, now let's look at example number 3. Example number 3 says 2 square root of a negative 8. So we've got 2 and then square root of a negative 8. Now let's break apart our rational number. So underneath our square root, we've got 2 times 4. And then if we break apart our 4, we've got 2 times 2. Now, this 2 times 2 is going to go ahead and going to come out. So we've got 4. So we've got 2 times 2. And it's a negative. So 2 times 2i times, and we still have this 2 over here that we need to take care of. So times 2, which is simply 4i, which is simply 4i square root of 2, because our 2 is left under. So it would be 4i square root of 2. All right, let's go here to example number 3. Now, how do we do imaginary numbers that are in actual equations? So let's figure that out. Let's set this up. 3x squared plus 10 equals a negative 26. So let's get a new board to work with. So it says 3x squared plus 10, so 3x squared plus 10 equals a negative 26. So equals a negative 26. Okay, so the first thing that we're going to do is we're going to subtract this 10 from both sides. So subtract 10, and the object always in an equation is to get a variable by itself. So the variable in this equation is x, so we need to get x by itself. So 3x squared equals a negative 36. All right, and then we're going to go ahead and get rid of that 3. So we're going to go ahead and divide by 3 and divide by 3. And then we've got x squared equals a negative 12. Okay, now again, we want to get x by itself. So we're going to do the square root to get rid of that x squared, and we need to square root on the other side. So we got rid of our square here, and we have x equals the square root of a negative 12. Now again, you cannot have a negative underneath a square root, so you're going to have to add an I. So let's break apart this square root. So we can go ahead and reduce the square root to 4 times 3, which is 2 times 2 on the outside. So what we're going to have is we've got, so our 2 goes on the outside, x equals 2 square root of 3, because our 3 still remains under the square root. So 2 square root of 3i. Okay, and the reason why it's I is because your square root, you had a negative number underneath your square root. So let's go ahead and do example number 4. It says 4x squared minus 5 equals a negative 25. So let's set that up. So we've got 4x squared minus 5 equals a negative 25. Okay, so again, we need to get x by itself. So first thing we're going to do is get rid of our 5 and bring it to the other side. So plus 5 plus 5. And we've got 4x squared equals a negative 20. Now we're going to go ahead and divide by 4 on both sides. So go ahead and divide by 4, and then simply divide by 4. And then we've got x squared equals a negative 5. Okay? All right, now we need to get x by itself, so we're going to go ahead and do the square root and the square root. Now again, you cannot have a negative number underneath your square root, so you're going to have x equals the square root of 5i. And then you're done. Okay. Let's go ahead and get a new board. Now, what we really want to talk about is complex numbers and how they're written. So complex numbers are written in what's called a standard form of a plus bi. Now, a are always your real numbers, and bi are always your imaginary numbers. So what it's going to look like is you're going to have 2 plus 4i, or a negative 5 minus 3i. So 2 is your real number, which is a, and 4i is your imaginary number, which is bi. And it's always written in this form. Complex numbers are always written in the a plus bi form. Now if we go down here to patterns of I every fourth, this talks about if you have I squared, it's going to be I. So an example is I to the first equals the square root of a negative 1, which is simply I. Now, if you have I squared, you're going to have negative 1, and the reason why is because I squared is the square root of a negative 1 times the square root of a negative 1, which is simply a negative 1. Okay, so I cubed is a negative 1, so I cubed is I squared, which is a negative 1, times I. So a negative 1 times I is a negative I. Now I to the fourth is a positive 1 because I to the fourth is I squared, which is negative 1, times I squared, which is negative 1, and that equals 1. Okay, so we're going to talk a little bit about adding and subtracting complex numbers. Now they need to be written in standard form, which if you can remember is A plus BI. So let's do this first one. It says 4 minus I plus 3. So 4 minus I plus 3 plus 2I. All right, so let's see what we've got here. We've got 4 plus 3. So all you're going to do is you're going to go 4 plus 3, which is 7, and a negative I plus a positive 2I, which is simply plus I. And that is your answer. All right, let's do the second one. Second one says 7 minus 5I minus 1 minus 5I. So 7 minus 5I minus 1 minus 5I. All right, so all you're going to do is you're going to take 7 minus 1 is 6, and a negative 5I minus a negative 5I. So we've got a negative and a negative is a positive, so positive. And then a positive 5I plus a negative 5I is 0. So you're simply going to get 6. Let's go over here to example 2. So we're still adding and subtracting numbers, but we've got this square root over here. So let's try this one. It says 10 minus I So 10 minus I plus 8 plus the negative square root of 144. Okay? Now, what you're going to do is this negative 144 is actually going to be the square root of 144 is 12, and it's going to be 12i because you've got this negative under here. So it's going to be 10 minus I plus 8 plus 12i. Okay? Because the square root of 144 is 12, and because it's a negative, it becomes an I. So 10 plus 8 is 18, and a negative I plus a positive 12i is just plus 11i. And that becomes your answer. Okay? Now, that's how you add and subtract complex numbers. Now let's do one example where we multiply complex numbers. So let's try example number 1. Or let's try example number C. It says 6 plus 3i. So 6 plus 3i times 6 minus 3i. So here we're going to use FOIL. Okay, so we're going to use FOIL to figure these out, both first, outside, inside, and last. So first,